Hi, I'm Chris Rakakis. I'm with JuliaHub here, and we're here to talk about Dyad and its connection to Modelica. So if you haven't heard about Dyad, it's a language for modeling and simulation, specifically acausal modeling and simulation that we've been developing at JuliaHub. A lot of the design decisions have come from Mike Tiller. You might know him from developing a lot of things like the Modelica University and Modelica by example, right? And a lot of these ideas of how could a next language look that uses a lot of the ideas from Modelica, but incorporates ideas of what are things that can streamline given how things have evolved in language usage have been built into Dyad, right? But now what we really want to talk about today is not necessarily just Dyad, but also how does the Dyad language connect to all the tooling of Modelica, specifically through FMI and the two-letter word there, AI, the scary beast in the room. So we'll have a lot of nice examples of that. So let me just give a quick primer on what Dyad is, right? If you would open up Dyad, here's the Dyad builder. If you were to open it up and have done Modelica before, you'd say, wow, this looks fairly similar to you, right? It's a acausal modeling language where you have components, you piece things together, there's code that goes with it, or that code then kind of changes things in the diagram. But now one of the differences with Dyad is that we have these things like what we call analyses. These analyses are these things that you can put in a lot of these parameters and can run certain things like, for example, it can do PID auto-tuning, it can train neural networks, it could do all these sorts of operations to a model, right? So here you can see that, there you get all these sensitivity functions, Nyquist plots, Bode plots, and such from an acausal model, right? So what we're really focusing on with Dyad is not just the modeling aspect, but how can we improve all the kinds of things that you can do with a model, right? And so, oops, let me go back into this here. And so we have a huge focus on all these things that if you had a model, what are the kinds of things that you could do to that model, right? So for example, okay, you can always find a steady state, but you could also do things like calibrate it to data. You can build a surrogate of the model, all sorts of controls analyses like linearized models, do closed loop sensitivities analysis, yada, yada, yada. Also do things like model discovery, right? These are things like, what people are talking at the conference, like Penn ODEs or universal differential equations, doing things like training neural networks to match missing data and learning the missing physics, right? So we have a lot of these things and we have a lot more of this coming soon, including, GPU accelerated parameter sweeps. And then your question that anyone would like to ask is, well, if you have all those things that you can do to a model, wouldn't it be great if we could integrate this with Modelica models, right? And so I'm going to get to that part, but let me go a little bit further. So a lot of what Dyad is focused on is this kind of combination of scientific and generative AI, right? Scientific AI or scientific machine learning is the usage of scientific models to be able to constrain what the machine learning is allowed to learn. It's using prior knowledge, prior physics, and making sure that that is true by design in the machine learning that you're doing. And we're doing a lot of mixing of that with generative AI, which is this kind of, the large language models for accelerating coding and this. So this is really what we've kind of been focusing on as a difference and really a strong tenet as to, different changes to the language that we need to do in order to incorporate these kinds of features. And so, I want to kind of just highlight that there are a few reasons why we kind of came up with a new language. And again, I think that someone who's great to talk about with this in a lot of detail, if you're kind of curious, would be someone like Michael Tiller, to kind of talk about, all the kinds of things like first-class support for optimization within the language, new design to, a new design to some of the standard libraries, using widely adopted open platforms like SVG, VS Code, package managers, and Julia as part of the core tenets of the language, and also changes to the language that can help increase generative AI accuracy. So there's a lot of things that we've done to make it so that way Dyad would be a kind of next generation and a growth of a lot of acausal languages. But we still want to integrate with the Modelica community. So how do we piece all this together? And one of the first ways that we're doing a lot of this is integrating Dyad with Modelica through Dyad's generative AI capabilities. So one of the things that we have with Dyad is we have a Dyad Copilot. Here you can see on the right, we gave a prompt to tell it to add a PID component. So there was an active suspension model, and we told it, hey, add a PID component to this model. And you can see that it then gives you this all this code in here that you can accept or reject. You can see that it has added some new components and new connection statements right there into the model, right? And so we built this as kind of like a first-class feature where I think a lot of our older scientists were a bit scared, like how accurate could this thing be? But as people really started to work with this more and more and more, we found that this is a very helpful tool where, for example, if you can't remember how to make a certain plot, right? If you're like, oh, I don't remember the right buttons to make a Bodhi plot, it's kind of really simple to just say, hey, AI, make a Bodhi plot of this, or this, and then boom, it's able to kick out plots. So, you don't need to rely on the generative AI to do all the modeling for you, and I'd be happy to, if you're really curious about how this works, you can come to our booth and play with it. Come talk to Anshul. Be like, oh, does it work? Does it get this correct? Does it get this correct? It's really fun to play with. So yeah, all your questions about how well it works, give it a try. But one of the fun examples that we have with this is actually we took a case where we have a diagram from SCADE, right? And we just said, hey, here's an image, right? Here's a picture of a diagram from SCADE. And then we just said, hey, can you translate this into Dyad code? And using our translator that we have internally, and was able to actually kick out a library using block components that was then able to then reproduce it in code. And of course, it might not know the gains of all the things and everything, right? But it gives you out a reasonable code that's a good starting point to then build your model, right? So a lot of these generative AI tools are kind of cool. And then, the question everyone asks is, oh, if I go up to a whiteboard and I just draw something, could I take a picture of it and have it start your code? The answer is if you use blue marker or if you use black marker but not red marker. I'm just kidding, but we can test it out and see if there's any issues like that. Again, there's really fun stuff to play with. So if you're really curious, come to our booth and we'll be happy to get you set up and playing with some of these Dyad Gen AI tools. But one of the key things here is that, these LLMs show, I just kind of pointed out, these LLMs tend to show very high accuracy for some languages rather than other languages. For example, a lot of open benchmarks have been showing that, for example, the Julia programming language gets a lot more accuracy with LLMs rather than Python, C++, and JavaScript due to things about the compiler feedback in terms of what types of type information it gives back, but also the designs of the language itself, right? So we've been kind of designing Dyad to be in the style along with Julia to make sure that it can kind of hit this high accuracy with LLMs. And so one of the things that we've then been doing is we've been saying, okay, in order to be able to use this system, we're going to assume that a lot of people have Modelica models. Let's see if we can do bulk translation from Modelica. And you might think that, okay, I've tried using ChatGPT in a Modelica model to, MATLAB or something, and it failed, right? And I'll go, yeah, when we tried this at first, it completely failed. But that's not the approach that we took here. So with the Dyad Model Translator, we have something built into our system where what it does is it parses the actual Modelica code, right? It parses the Modelica code, and it understands some of it. It says, okay, this component, I know what this looks like in this library. I know, and so it can actually do like a direct translation for a lot of things. And it goes, well, actually, I don't know for this component. I don't know what this equation is. And it only uses the LLM right there, and it reproduces in Dyad what the whole piece is supposed to be. So you're guaranteed to have the right number of components. You're guaranteed that the components are connected in the right way because all of that is done analytically. What's not done analytically is small little pieces that it just couldn't figure out before. And so, that's a giant diagram to just say, don't just let ChatGPT do everything. You use a special agentic approach that actually has a parser from Modelica and everything built into it. And when we do this, what we're able to find is that, we can translate through, in fact, the entire Modelica standard library in about 13 to 27 seconds per component. So I think it's like 1 to 10 minutes to be able to run through the whole library with this approach. And what we find is that in the runs, we actually got 313 of the components just correct, and 1,100 were not completed. And the only reason that they weren't completed was because Dyad does not use the replaceable syntax in the same way that Modelica does, which means that for everything that that was using language constructs that we supported, it was correct. And then the other things that it was not there, it was just trying to say, hey, look, I can't support this because you don't have that language construct. So we effectively hit 100% accuracy. I mean, there's details details there as with anything. But again, this is because it's not using just a straight LLM translation. This is a very specific agentic approach that was designed for this language. And so we're using this to be able to port over the entire standard library, and we're training the system over and over and over. And so this is how we're building out our standard library through making sure that the system can be built. And we're actually going to be opening this up as a feature for people who want to be able to adopt Dyad. Oh, it's open. All right. And so, but of course, if you're scared of the agentic AI tools, even though they're fun, go try them out at the booth. There's other ways that we integrate as well. So one of them is through FMU import and runtime. I think the best way to describe our FMU import is to look at an analysis that an alternative group did. So the group at ANSYS here, actually the ANSYS Twin Builder group, which is now part of Synopsys, took a look at the FMU capabilities in the Julia ecosystem and said, well, if we take some of these really difficult FMUs that we built and we run them in the Julia and Dyad FMU tools, what is the performance that we get? And what they saw was just generally across the board, just a general speed up of whatever of the against the FMI or the tool that they're using before. I believe that was FMPI, right? So again, this were not my benchmarks, so you can go talk to the, I believe his name was Adam, right? This is someone from ANSYS who gave this talk and said, hey, these are the numbers that we got when we used the Julia FMU tooling, and so therefore it had fast and robust tools for doing FMU import. Now, one of the things that people are always interested in as well is generating FMUs. And I think one of the things that some people who've used Julia before have thought of is, oh, but Julia has a runtime, it kind of builds some large binaries. This is kind of difficult. If you have something in the Julia ecosystem, it might be hard to connect with something outside of it. This is something that JuliaHub has been working a lot on over the last year. And so we have now this FMU generation, which works with the soon-to-be released next version of Julia. So Julia version 1.12 will have a new feature called Julia C with trim, which will make it so that way anything that's not used within a binary is cut out from the built binary. And so what this means is that even though we'd have 1 gigabyte binaries for our FMUs before, and they take like 20 minutes to build, after this, our FMUs are building, and they're giving us 50 megabytes, 40 megabytes. Now, a good 40 megabytes of that is actually just the BLAS, the matrix multiplication and LU factorization library. So we'd have to be able to cut that out to get much smaller. But the key thing is that this has been a bottleneck that we've seen with people who've tried to use earlier versions of this tool. So we just wanted to highlight that this is one of the major improvements that we've done to both the Julia language, and then this propagates up to the FMU generation of Dyad as well, as just improved FMUs. Where we then also, we've been able to show that the compile times are relatively constrained as well. This has been a major change, major improvement, because we get to some really large models with FMUs fairly quickly. We talk about things like building neural networks into FMUs, and for example, neural surrogates into FMUs to be able to be used with other tools. So, again, this is just one way to be able to connect with other tools, but this is one where we had a bottleneck before. We just wanted to highlight that this is one bottleneck that has been now relatively addressed, not yet, but in the version of Julia that's coming out about a month or two from now. So I think that's most of the time I had. I'm going to leave the rest for questions, but I think that the key here is, Dyad is a new modeling system. If you're curious, please give it a try. But I think that there's a lot of cool things that we're doing to be able to make sure that we can continue to work with the Modelica community, including tools for automated translation and tools for FMU import and export. And I think that this area of generative AI is, when you start to use it effectively, you don't, not just like it's throw it at ChatGPT, but when you start to actually include your own agents, your own Modelica parsers and all these things, you actually get to relatively high translation accuracy. And we believe that this will make it so that way we can more easily move between different tools and different vendors in the future to be able to build workflows that work with everyone's tools all in a very nice way. So thank you very much.